So today's lecture is going to be on, guys, shh, please, shh. Okay, your voices are on YouTube now, so be quiet. Yeah, I am recording. All right, today's lecture is all about solving equations involving exponents and logarithms. So we're actually not learning any new identities, but we're more learning about, useful applications of how we use those to solve equations that we encounter. So if we recall the 6 identities that we have learned, remember we have 2 inverse identities for the inverse properties of logarithms and exponents. So that is, right, a to the log base a of x is equal to x. Log base a of a to the x is equal to x. Okay, those are our 2 inverse properties. Then we have our addition property. Right, if we're adding 2 logarithms, their inputs multiply. So log base a of b plus log base a of c is equal to log base a of bc. Same applies for subtraction, but that becomes division instead. So subtracting 2 logarithms, we divide the inputs. Remember, the bases have to be the same in order for any of these rules to apply. Then we have multiples of logarithms. That becomes an exponent of the input. So if we have n times log base a of b, that is equal to log base a of b to the n. Then finally, we have the change of base formula that we just looked at, right? Log base b of c is equal to log base a of c over log base a of b. And that allows us to change our logarithm to any base a that we would like, as long as a is positive and not equal to 1. All right, questions about these 6 things? We're going to want to memorize these. And a lot of you have already used them well in the quiz, so we're all good. All right, so today we're just going to go through a bunch of examples of possible equations that we might encounter, and we're going to go through some strategies for solving them. So let's start with an easy one. Let's say we have an equation 2 to the x equals 32, and our question asks us to solve this equation, which means to solve for x. What are some ways that we can do this? Very easy one, right?
Change your base form for the
Other one?
First, make it log base 2 of 32.
Okay. Mia?
Why don't you just make 32 into, like, what's it called? Change the base to 2.
Sure, make it into 2 to the 5?
Yeah.
Yeah, both of those ways work. Yeah, both what you two said, good. So the first way, which Mia suggested, is to make 32 into an exponent with base 2, right? And this allows us to use our 1-to-1 property, and we can just immediately say x equals 5. Right? Super easy. Another thing we could do is take a logarithm of both sides, right? The idea is that we have an exponent, 2 to the x, so we have an exponent with base 2, and if we wanted to get rid of the exponent, we could do that by taking a logarithm of both sides with the appropriate base, because that's what kind of helps us to so-called, we could say cancel out an exponent. So we could take a logarithm of both sides, log base 2 of 2 to the x equals log base 2 of 32. And so the left side simplifies to x because of our inverse property, and the right side is just 5 by a simple calculation, and that gives us the same answer. Okay, so when we solve exponential equations, those are kind of the 2 main ideas we want to use. One is either we want to make the bases the same, or secondly, take a logarithm of both sides to get rid of the exponents. Questions? Let's do a slightly harder one. Let's say we have 1/3 to the x equals 9, and we wanted to solve for x. How would we do it the first method, making the bases the same? Yeah.
We would square 9, or cube root 9, and then put that to the power of 3 on the side, so
Okay, I think you mean make it a base 3, so 3 squared. 9 equals 3 squared, okay. How about the left side, anybody?
Put a negative exponent.
Good. And the reason we want to do that is because that will make our left side also a base 3 exponent. Okay, so that's the idea. That would be a negative exponent. So on the left side, if we make 1/3 into an exponent base 3, that's going to give us 3 to the negative 1, all to the power of x. And of course, that simplifies to 3 to the negative x equals 3 squared. So negative x equals 2 and x equals negative 2 by our 1-to-1 property. Okay? So here we use the fact that both 1/3 and 9 are exponents of 3, which helps us to get both sides under the same base. That's the kind of idea that we're using. Very, very common approach to solving things. Okay, questions? Let's do a similar one, just another example. Let's say we have e to the x equals 7. Okay, 7 is not a power of e, so how would we go about solving this? Okay, natural log, what does that mean? Yeah, whatever everybody said, right? We take a natural logarithm of both sides, if somebody said that. Okay? So, right, here we want to get rid of our exponent and leave us with only x. And the best way to do that is by taking a logarithm of both sides with the appropriate base. Quiet, please, friends. All right, a natural logarithm of both sides will help us to eliminate the exponent base e, right? Because, natural log is also base e. So the left side simplifies to x because of our inverse properties, and the right side doesn't simplify, so this is all we're left with. Okay? On the homework, okay, so on the quiz, this would be acceptable because natural log of n doesn't simplify. But on the homework, you might have to get this into a decimal format, which will require a calculator. Okay? Anybody want to quickly do this calculation with their calculator? I think it would be about... I don't think so. I thought it would be like about 2.
One point.
Am I supposed to be degrees or radians? Or
Doesn't matter. That sounds more correct.
1.946.
Yes.
Wait, what's wrong with that? No, it's the side of the same thing.
Oh.
Oh. I didn't hear this answer though. But that's approximately what it would be about. Right? Because e is around 2.718, and the square of e is around 7. So it should be close to 2.
Why'd you erase that?
Because it's irrelevant. Just some mental calculations. Okay, next one. Are we all good with this slide? We're all good. All right, next one looks hard, but is pretty easy. Okay, let's say we have e to the negative x squared equals e to the negative 3x minus 4. How would we solve for x? I'm looking for property, something property.
1-to-1.
1-to-1, thank you. Right, because our exponents are the same, that means the exponents, okay, I don't know how to say that, but you guys know what I mean. Negative x squared equals negative 3x minus 4 by our 1-to-1 property. And we just simplify this. All right, can anybody tell me the answer already?
X minus 4, x plus 1.
Nice, very good.
X equals 4.
And negative 1. Yep. Very nice. Okay, So if we plug these back into our equation, do they both work? The answer is yes, they both work.
Yeah, sure.
Okay, because exponential functions have a domain of what? All real numbers, right? So actually, exponential functions, they take pretty much any value, so we essentially don't really have to check our solutions when we have exponential equations. Make sense? Logarithmic equations are a different story, of course, because they have a limited or a restricted domain to only positive inputs. But because we have an exponential function here, no matter what x is, these exponents are totally fine. So that's our answer, x equals -1 and 4. Okay, questions? Not too hard, right? All right, let's say now, this is more common on the homework. It's not hard, but we should understand how to do it. Let's say we have 3 times 2 to the x equals 42. What should we do first? Yeah, we should divide by 3. That helps us to isolate the 2 to the x. And now what is x here? Log... Somebody?
Log 2, 14.
Yeah, log base 2 of 14. Just based on the definition of a logarithm, right? Alternatively, you could have taken a logarithm of both sides, base 2, and that would have given you the same thing. Oops. Okay, and so on the quiz, this is what you would write. X equals log base 2 of 14, and then 14 is not a power of 2, so this doesn't simplify. On the homework, you might have to calculate this. Anybody know what this is? Somebody confirm?
3.8, 0, 7.
Yeah, very good. Okay. All good. Those are some examples of exponential functions that you should know how to do, both for the quiz, test, and homework. Let's go on to some logarithmic equations. So for exponents, right, the idea was sometimes to get rid of an exponent, we take a logarithm of both sides. But for logarithmic equations, sometimes it's very helpful to get rid of the logarithms by taking an exponent of both sides. So that's the idea that we're going to counter a lot. Let's say we have an equation ln of x equals 3. How would we solve this by taking an exponent of both sides? We use e, right? Because ln is base e. Actually, I learned the official word. It's exponentiating both sides. Okay, that gets rid of our logarithm, right? Because of our inverse properties. So we quote unquote exponentiate both sides, and the left side simplifies to x because of our inverse property, and the right side is e cubed. Doesn't simplify, so on the quiz this is good, but on the homework, somebody calculate this. Somebody.
20.09.
I believe it. Okay, 20.09. Anybody know how many sig figs that is?
4.
Nice. What classes do you guys learn sig figs in? Is it just chem?
Chem honors.
Mm. It's very important for all fields of science, though. So, okay, let's do another one. Another not too hard one. Let's say we have ln 5x minus 1 equals ln x plus 7. What shall we do here?
Don't they cancel out because if there's two like logs between like.
This is also known as,
1-to-1 property.
thank you, one-to-one property. Cancel out is a little vague, so one-to-one property, more official. Okay, so that leaves us with 5x minus 1 Because the logarithms are the same, their inputs must also be the same because they have the same base. So we solve this. What is x equal to? Nice. Good mental math. Okay, I'll do it out. 4x equals 8, so x equals 2. Now for logarithmic functions, we definitely do have to plug it in and check our answer. Because, right, what is the domain of a logarithmic function? Greater than 0. Right? If we recall the graph of our log function, it really only takes positive inputs. That's a rule that I asked you guys to memorize. Logarithms can only have positive inputs. And so we need to check to make sure that our solution for this equation only gives us positive inputs. And if it gives us a negative input, then that means this solution is extraneous. It doesn't work. But when we plug in x equals 2, what is our input on the left side? 9. And 9 on the right side too, right? So we're all good. This solution works. And we can box it. Questions? Next example. Slightly more tricky. Let's say we have ln 3x plus 14 minus ln of 5 equals ln of 2x. What's a good first step?
Combine the left.
By?
Subtraction, division.
Yes, that thing, right? So when we subtract two logarithms, that corresponds to dividing their inputs. So we can do that on the left side, which simplifies to ln of 3x plus 14 over 5 equals ln of 2x. Can anybody see the answer yet? X equals? Nice, 2, yes. But we'll apply our one-to-one property, which gives us 3x plus 14 over 5, right? Same logarithm, so same inputs. Which leaves us with 3x plus 14 equals 10x. So 7x equals 14, and x equals 2. Okay, now does this solution work? If we plug it in, do we get only positive inputs? Yes, right? The left side is 20, and the right side is 4 on the insides. So this solution is good. Okay. So, solving these logarithmic and exponential equations, we're really just applying the properties that we've learned already, which is why we need to be so proficient with logarithms and be able to solve this in 5 minutes. Okay? I think you guys did pretty well on it overall, though. I didn't see any wrong answers yet.
So does that mean we can just do mental math on the test?
If you want to get points off when you get it wrong, then that's fine. Oh, actually, I just saw a wrong answer. It's okay. Okay, let's do another one. Let's say we have 5 plus 2 ln of x equals 4. Not too hard. What should we do first? Yeah, we should try to isolate the ln of x, right? So we can subtract 5 from both sides. That gives us 2 ln of x equals negative 1. And finally, ln of x equals negative half. Now, can a logarithm have a negative output? The answer is yes, it can have a negative output. Can't have a negative input, right? Yes, Ron?
Wouldn't the 2 go like the x squared?
What?
Wouldn't the 2 like become like log natural x squared?
That's also okay. I can maybe show you guys how to do that later. But a little easier if we bring it to the other side. Right? If we graph our logarithm It looks like this, right? So it takes all positive inputs, or only positive inputs, but actually it can have any output you want. So that was a trick question. This is totally okay. Okay, now what should we do? We have ln of x equals -1/2. What shall we do?
Add e for the
Yeah, we should exponentiate both sides. Make both sides an exponent of e. E to the ln of x equals e to the -1/2. So the left side simplifies to x, and the right side does not simplify, so we'll leave it at that. Okay? Anybody want to do this in their head? E to the -1/2? I did it in my head in my 1A, and then the class was, flabbergasted. So
What did you get?
Oh, wait, yeah, it works, right?
what?
Because ln to e 1/2 cancels out to just be.
Yeah. So yeah, if we check our answer, it's good. But I was talking about making simplifying this in my head.
What is it? What did you say in your head?
Let me try to figure it out again.
Point
Alright,
something,
wait.
point six.
Shh. Right? I'll show you how I do it in my head, okay? This is just e divided by the square root of e. Sorry, 1 divided by the square root of e. And e is about 2.718, right? We all memorize that? Okay, so how do we take the square root of 2.718? Right? You guys don't need to take notes, obviously, right? Well, we memorize our perfect squares, right? So we know that 16 squared, or 1.6 squared, is around 2.56. And then 1.7 squared is around 2.89. So I know that the square root of 2.718 should be somewhere in between here. And it should probably lean closer to the 1.7. So I'm going to say that's about 1.67. And then obviously 1 over 1.67 is just 1 over 5/3, which is equal to 3/5 or 0.6.
Whoa.
Right? It's trivial.
I just got 1.6, I was not expecting you to get 2.
All right, this is just how you do these kind of guessworks.
Wow. Don't expect me to do this.
But like you guys understood every step I did, right? It's not too difficult.
That doesn't mean we can do it. So don't put that on the test. Please.
All right. But okay, let me show you guys how we do it Ruhan's way. So what Ruhan was saying is that you could also use our, what is it called?
Calculator?
No. Multiples of logarithms identity, right? So this is also equal to ln of x squared, right? We all agree? Because we can take our exponent that comes over to our multiple, to a multiple of our logarithm. Okay, that's just our, this thing? I should really try to know the names of these things. Right, that's just, we applied that identity. And so that will give us ln of x squared equals -1. If we take exponentiate both sides, make them both base e, then we get e to the ln of x squared equals e to the -1, which leaves us with x squared equals e to the -1, or x equals e to the -1/2 if we take a square root of both sides. So we get the same answer. Okay. There are a lot of ways to do these kinds of things. All right, let's do our final one, and we're done, amazingly. Let's say we have log 5x. Okay, what base is this?
10.
Very good. When I don't write a base, that means it's base 10. Log 5x plus log x minus 1 equals 2. Okay, what's a good first step here?
Combine log.
Yes, because when we're adding logarithms, the inputs multiply. So the left side is equal to log 5x times x minus 1. And the right side is equal to what? 2. Okay, that's not what I was trying to say. But from here, what is the best way to proceed? How do we get rid of a logarithm?
Times it by 10, or exponent.
Yes, very good. We make both sides an exponent of 10, all right, because that's our base of the logarithm, so that will help us cancel these things out. So we do that. 10 to the log 5x times x minus 1 equals 10 to the 2, which is 100. So on the left side, by our inverse property, the exponent cancels with the logarithm, and we're left with 5x times x minus 1. And on the right side, we have 100. Okay, we can simplify this. 5x squared minus 5x minus 100. Divide both sides by 5. Well, probably should have done that already. But that leaves us with x squared minus x minus 20. How do we factor this?
-5 and 4.
Very good. Looking for two divisors of negative 20. That adds to negative x, so that's negative 5 and 4. And we're left with x equals negative 4 or 5. Are we done? Of course not. We have to, we have to plug it back in. Which one doesn't work?
-4.
Right. Why is that? Because that makes this a negative input. So we know that this is extraneous because it makes our second logarithm, right, log x minus 1, not valid. So we say this is extraneous. 5 is all good, right? That would be log 25 plus log 4. That's all good. So our final answer is x equals 5. Okay, general rule, whenever you have an equation with logarithms and x inside the logarithms, you always want to check your answer. Exponents is fine. They're always going to work. Final questions. Yeah, Julie.